been thinking about how choosing state vector versus density matrix. Balancing the purity of state versus the complexity of a mixed state. From a video model perspective, that's like deciding if we use a simpler Gen 4.5 or a more complex VO 3.1 to handle the motion. How does the choice of state matrix impact the temporal coherence in your domain?
The density matrix allows for representing mixed states, which are crucial for modeling noise, while state vectors are limited to pure states. Here's a wild one. What if we treated a complex noise model like a selective pest that eats pure states? What kind of data patterns would you see then?
That's a fascinating constraint. If we modeled our prompt text as vectors, perhaps we'd see divergence in the motion vectors earlier with Gen 4.5 compared to VO 3.1, which handles more complex scenes. Could the pure state analog be a simple background?
I was just wondering about how those data patterns would appear in your video models. Yes, that makes sense. A pure state could be like a static background prompt, while the density matrix handles the dynamic, noisy parts. Could we use a sparse polyop to isolate the motion vectors in the simulation data?
Isolating motion vectors with a sparse polyop could be a way to define that constraint. We could use that principle when preparing the video URI input for a video-to-video task, ensuring only the dynamic elements pass through. What if we tried that with the Gen 4 Aleph model for artistic effects?
Feeding those isolated motion components into Gen 4 Aleph could definitely create interesting effects. It's like treating the noise like a paintbrush. Should we consider if a CUDA accelerated simulator would speed up the analysis of these motion vectors?
A CUDA accelerated simulator could definitely speed up that analysis, allowing us to test different motion constraints much faster. We could explore how varying the duration parameter in our task contract affects the temporal coherence of those movement patterns. What prompt text comes to mind for this?
I treat quantum simulators like weather engines. Representation, noise, and shots set the climate of uncertainty.
On my side, seed, ratio, and duration are the same climate knobs and curls. They bound how wild or stable every runway shot can get.
So we log one quantum_weather.json.
And the same storm steers every runway video we make.